All right, folks, welcome back to section 10.4, Trigonometric Identities, and now is when we get into the example problem. So the first video went over all the formulas, but it just kind of basically showed you the formulas, kind of came up with a couple of derivations of where those formulas come up from, but really didn't show you how to use them. And that's what we're going to do now is we're going to get into an I have 10 different example problems here that if you take the time and effort to go through each of these example problems, you'll be set up for success in WebAssign. In fact, for each example problem, I kind of tell you which WebAssign questions correlate to that problem. So let's go ahead and without further ado, get started. Our first example problem here says to find the exact value of the following, and there's two different trig ratios here we have to find the exact value of. Just as a quick comment, this applies to questions 1 through 7 in WebAssign, and you'll be using the sum difference formulas from our notes on these problems. All right, so if I'm looking for the exact value of the following, this should be pretty easy, right? Because we've memorized a bunch of different values from the unit circle, and those should help us whenever we need to answer a trig question, right? Well, this is where we run into a problem because I'm a little concerned by this angle right here, 7 pi over 12. That is not one of the angles that we learned on the unit circle. It's not pi over 2 or 3 pi over 4 or anything like that. It's 7 pi over 12. And that's a problem. Well, fortunately, we learned a whole bunch of formulas that could help us. And I'm going to go back and refer to one of those formulas right now, the sum difference identities. And for this problem, we're going to look at the sum difference identity for cosine. Okay, that is starred there. It's one of the ones you have to remember, and it is cosine of alpha plus or minus beta equals cosine alpha cosine beta minus or plus sine alpha sine beta. So that's the formula we're going to use. And the one thing I want to comment here about the sine and cosine is, and I mentioned this in the previous video, but if you look at this sign right here and then this sign right here, they are opposite. If you go over to the sine formula, you'll notice that those two are the same. So, how can you remember those? So a student last year said, hey, Mr. Vass, I have a great way to remember that. For sine, they are the same. Okay, so that's how I remember that now, that if it's alpha plus beta for sine, it's going to be plus between these two different things we're multiplying. For cosine, if it's plus two angle measurements, then it's going to be minus here. Okay, so now let's go back and actually look at the hard part of this problem. The hard part of this problem is figuring out a couple angles that we know that add up to 7 pi over 12. And here's where our work with the unit circle comes in handy. Any angles that we've learned on the unit circle we can use here. And what we're going to try to do is find out two angles that either add or subtract to give us 7 pi over 12. I'm just going to take a guess here. I'm going to guess that maybe I can use pi over 3 and pi over 4. Let's just see what happens if I add those two angles. Well, pi over 3 plus pi over 4. Directly, I can't add those two together as is because they don't have a common denominator. So the common, let's see, the common multiple there is going to be 12. So I'm going to do 3 over 3 times this one and 4 over 4 times this one. And let's see what that gives us. So that's going to be 4 pi plus 3 pi. That gives me 7 pi. And then my denominator is 12. Oh, hey, look, that's the angle I was looking for, 7 pi over 12. So if I add pi over 3 and pi over 4, I'm going to get 7 pi over 12. That's the hardest part of this problem, because in some of the problems you're going to see in WebAssign, you're going to have to kind of do a little bit of guess and check to see what two angles add up to give you the angle that they're asking about. All right, so now I just jump into the formula. The formula for cosine alpha plus beta is this. Cosine alpha plus beta equals cosine alpha times cosine beta minus, remember sine is the same, cosine is different, sine alpha times sine beta. Okay, so now it's just a matter of kind of plugging in the values I know and then simplifying. So I'm going to identify pi over 3 here as my angle alpha, and pi over 4 will be my angle beta. And see if you can follow along. Congratulations, folks. There's our first application of a sum or difference formula. We found the exact value for the cosine of 7 pi over 12. It is root 2 minus root 6, all divided by 4. And one thing I do want to encourage you to do is, for those of you that are interested, I've showed you back on our reference sheet here, I've showed you what all of these formulas are. Your textbook does a very thorough job of deriving many of these formulas. So if you want to know how the cosine of alpha plus beta ends up being cosine alpha cosine beta minus sine alpha sine beta, go back and read in your textbook and see how your author has derived many of these formulas for us. Okay, so back to the example. Now we're going to look at tangent of 7 pi over 12. Well, fortunately, I already know 7 pi over 12 is equal to pi over 3 plus pi over 4, and I know that because from the previous problem. So I'm going to stick with my assignment here of alpha to be pi over 3 and beta will be pi over 4. Now the tangent formula for some difference, a tangent of an angle, that is not one that you need to memorize. That's one that will be given to you on any test. So I'm going to go ahead and write it out for you here. You could get it off your notes page, and then we will sprint through this problem. All right, one thing that you're going to encounter with this problem is, as I write this formula out, you can see we need to know the tangent of pi over 3 and the tangent of pi over 4 in order to do this. And sine and cosine we have memorized from the unit circle, but tangent we often don't memorize, so we kind of have to think through it a little bit. And we're going to take just a second here to think through this. So let's see, tangent of pi over 3. Well, I know that tangent is equal to sine over cosine. So let's see, the sine of pi over 3, that's root 3 over 2. And then the cosine of pi over 3, that's 1/2. Oh boy, I hope you remember how to divide fractions, folks. Remember all that stuff back in whatever 4th or 5th grade they taught you how to divide fractions? You thought you'd never need that again. Well, unfortunately, we do. We need it for the work we're doing here. So that's tangent of pi over 3. Tangent of pi over 4 is an easy one. You should be able to kind of come up with this one without even deriving it, but I'm going to go through it here just so that we can say we've seen it. So let's see here. So the sine of pi over 4, well, that's root 2 over 2. And the cosine, that cosine is root 2 over 2 also. So I have root 2 over 2 divided by itself, that equals 1. So that's kind of interesting. When the tangent ratio is equal to 1, you know that you've got an angle of pi over 4. Okay, so great. Now we're going to go ahead and take these values and substitute them into the sum difference formula for tangent. There you have it, folks. Pat yourself on the back. You just did another application of a sum difference formula. This one was tangent. One thing I will highlight for you is that if you notice here, I have an irrational denominator. My denominator has a root 3 in it, and that is an irrational number. So rationalizing a denominator that means getting rid of any irrational numbers in there. That is a computational skill that really isn't necessary anymore because we have things like calculators and computers that can do it for us. However, it's not one of those bad things to know how to do in case you want to impress your family and friends. So if you want to know how to rationalize 1 minus root 3, I'm going to encourage you to look at the hard copy of my notes online, and you'll see how to do it there. So to turn that 1 minus root 3 into something that's rational. It might even involve the conjugate of 1 minus root 3. So if you're interested in that, take a look at the hard copy of the notes. Let's go ahead and take a look at another example here. All right, folks, let's take a shot at example 3 here. First, I'll just highlight that this problem correlates to web assigned examples 8 and 9. and we're going to be using double angle formulas. If you refer back to your reference page, double angle formula showed up at the top of page 2. That was the top of page 2. There are 3 versions of the double angle formula. The double term comes in because it's 2 theta as the input. There are 3 different versions of the formula for cosine 2 theta. You can honestly, if you can memorize one of those, you should be able to derive the others. And how can you derive the others? Well, cosine squared theta minus sine squared theta. I'll just, that might be a nice little break here. Let's just do that. So cosine squared theta minus sine squared theta. And this is the double angle formula for cosine of 2 theta. So let's just take a look at the sine squared theta piece. I remember this. The Pythagorean trig identity says that cosine squared of theta plus sine squared of theta has to equal 1. That means that the sine squared of theta is equal to 1 minus cosine squared of theta. So I can just do a little bit of algebra there to manipulate this equation and make it and solve for sine squared of theta. So now I can substitute this relationship right here in for sine squared of theta, and this is what I'll get. I'll get cosine squared theta minus the quantity 1 minus cosine squared of theta. And if I distribute the negative and combine like terms there, I'm going to have 2 times the cosine squared of theta minus 1. And lo and behold, that matches with this second formula for the double angle version of cosine 2 theta. So again, if you memorize any one of these 3, you could derive the others if you needed to. So I don't want to tell you have to memorize 3 different formulas. Pick one that you're comfortable with, memorize it, and then derive the others, or just if it's easier for you, memorize all 3. Again, cosine double angle, sine double angle, those are ones that you have to know. All right, back to our example here. This problem says if the sine of theta equals the variable x divided by 3 for negative pi over 2, theta between negative pi over 2 and pi over 2, find an expression for cosine 2 theta in terms of x. So they're giving me some information about theta through the sine ratio, and I have to convert that to information about the cosine of 2 theta. So one of my favorite sayings is picture's worth 1,000 words. So we're going to go ahead and see if we can draw this angle theta and get some information about it. So the first thing I notice here is that theta is between negative pi over 2 and pi over 2. That means it has to fall down here in quadrant 3 or quadrant 4, or up there in quadrant 1. So we're going to restrict our analysis to those 2 quadrants. The second thing I want to talk about is this relationship here, the sine of theta equals x over 3. Well, I know from the work that we've been doing that the sine of theta is always going to be equal to the y-coordinate of a point on a circle divided by the radius of the circle. Now for the unit circle, the radius is 1, so it's just sine of theta is equal to the y-coordinate. But now we have this value here of 3 in our denominator, so we're going to look at a circle with a radius that's not 1. And let's take a look at what happens here. So I'm going to just try and sketch an angle theta here. I'll pick the first quadrant just because it kind of makes things nice and easy for us, and we're going to label that angle as theta, and I'm going to just sketch a circle in, or excuse me, that's not a circle, it's last time I checked that's a triangle. I'm going to sketch a triangle in around that, and let's see what we can come up with about this triangle. So I have this angle theta. I've chosen to draw it in the first quadrant. Now let's take a look at what the sine of theta equals x over 3 tells us. Well, the y-coordinate, or this vertical distance right here, is x. So I'm labeling that dimension there, that vertical length, as x. And then the radius of the circle is 3, so that means the hypotenuse of this triangle is 3. So now we could use the Pythagorean theorem to figure out what this horizontal leg is. And this horizontal leg will be the square root of 9 minus x squared. And you might be wondering, hey, where'd that come from, 9 minus x squared? Well, that's the square of the hypotenuse minus the square of that other leg. So let's write that a little neater there. That's 9 minus x squared, the square root. So that expression there, the square root of 9 minus x squared, is what this horizontal leg is equal to. So I've kind of identified everything I can about the horizontal and vertical lengths in this triangle and the radius. So now let's go jump back to the double angle formula and see what we can get. So I'm going to go ahead and use the one that I was talking about before. We'll use the cosine squared of theta minus sine squared of theta. And again, you could use any one of those three relationships. In fact, that might not be a bad exercise for the user, is to use all three of those different relationships and see if you come up with the same answer. Okay, so let's see what we know. The cosine of theta is, well, that's going to be the adjacent leg over the hypotenuse. So that's going to be the square root of 9 minus x squared divided by 3. That's the cosine of theta. I have to square that. Then I have to subtract the sine of theta. Well, the sine of theta we were given is x over 3. And I have to square that. So let's take a look at what this looks like now. So cosine of 2 theta. If I square the square root of 9 minus x squared, I get 9 minus x squared. Don't forget to square your denominator as well. And that's going to be minus x squared over 9. At this point, we have two fractions that we have to subtract one from the other. They have the same denominator. So from this point, it's a can of corn, folks. We're almost done. 9 minus x squared minus another x squared is going to be 9 minus 2x squared. And my denominator will be 9. So look at that. We came up with an expression for cosine of 2 theta in terms of x, and that's what they asked us to do. Folks, listen, I'm going to be honest with you, that was so fun. I'd like to do the sine of 2 theta as well. I know that we weren't asked to do that, but I'm really fired up about this. So for fun, I want to do the sine of 2 theta as well. The sine of 2 theta, the double angle formula for sine, is 2 times sine theta cosine theta. So let's see what we come up with on this one. There you have it, folks. Little bonus problem for you there. The sine of 2 theta is the quantity 2x times square root of 9 minus x squared, all divided by 9. That's about it for this video. Stay tuned for examples 4 through 10 in the next couple videos.